Right, rectilinear motion. Question 1 then, let's have a look at this. It says, at time t seconds, the velocity v of a particle moving on the x-axis is given by this here, okay? So you've got your, it's in terms of v, yeah? And then it says, find the acceleration of the particle at time t seconds, given that when t equals 0, x equals -3, find the displacement of the particle when t equals 2. Okay, let's focus on A to begin with then. Alright, so we're given v equals 3t squared plus 10t to the power 4. Alright, now this is velocity. Okay, from velocity we can get acceleration, we can also get displacement. Okay, we need to remember to get acceleration we need to differentiate velocity. Okay, right, because acceleration looks at the rate of change of velocity. Yeah, how velocity is changing. So we do dv by dt. Okay, so to get acceleration, you differentiate this, so you get 6t, and then bring that 4 down, 4t then t cubed. Okay, so we found the acceleration there at time t seconds. There's our answer. Part B, it says, given that when t equals 0, x equals -3, find the displacement. So to get the displacement, again, you need to work from the velocity. Okay. Now, to get displacement, we'll call this S, right? Obviously, displacement we think of as S. Now, to get from V to S, the displacement, we need to integrate, yeah? Because if you remember, velocity is the rate of change of displacement. So to get back to S, we need to actually integrate velocity to get back to S. Now, one way I want you to look at this is to rewrite V as the derivative of S. That's the way I would want you to do it. Okay, so you're rewriting V to start with as ds dt. Okay, and I'm going to write the same thing down, aren't I? Because that's what it is. Ds dt is just velocity, and then I'll go about integrating it. Okay, it's important to do it that way. Now, when I integrate, okay, what I'll do, I'm going to separate the variables. Think of this as like a differential equation, and we're doing C4. So you separate the variables, get the t's on one side, s is on the other side. So we've just got a ds here, okay. So we'll be integrating that, and you take the dt up and you multiply it. So then we're going to have 3t squared plus 10t to the power 4 dt. Okay. Now when you integrate here, you've just got ds, right? Now that really means 1 times ds, yeah? Because there's nothing there, it means 1 times ds. So you're going to integrate 1. When you integrate 1, you get s, okay? And then you integrate this side, so 3t squared. When you integrate it, of course, you raise the power, cube divided by that new power. And then here, integrate this C2 work here, isn't it? You integrate that, you raise the power to 5, divide by 5, and then don't forget to add on a constant with the integration. You can simplify this, so that's t cubed plus 2t to the power 5 plus c. Alright? Now, often, right, they will give you a situation, it's quite clear here, isn't it? They give you boundary conditions here. That's necessary to work out c, okay? So it says here, given that when t equals 0, x equals -3, find the displacement of the particle at time t equals 2. Okay, you notice here they've used x, okay, for displacement, okay, whereas we used to using s. It really doesn't matter, okay? So, you know, when t equals 0, okay, x, okay, or s equals -3, all right? So we've got -3 sub it n equals, you know, that all becomes 0, and then you get your c there. Okay, so c will equal -3. All right. So you end up having your displacement then, your final solution. Now, given that they have put it in terms of x, we could call it x if we want, t cubed plus 2t to the power 5, and then the c is -3. Okay, so we've got our general solution. Okay, this is our general solution. That's our displacement at time t. All right, and we can use that for anything. We can now use this to work out, find the displacement when t equals 2. So all you've got to do is say, look, when t equals 2, x will equal 2 cubed, just sub it in, plus 2 to the power 5 -3. Okay, so then you work that out. You can work that out on your calculator. It's late in the day, so I will work this out on my calculator so I don't make mistakes and don't get complaints. So 2 cubed, where are we? 2 cubed plus 2 times 2 to the power 5, and then minus 3. So you get your answer then, x equals 69, and you can put meters there as well if you want, and the question's answered.